Okay, so welcome everyone to this webinar on dependency management. My name is Louis and I'm part of the dependency management team, and with me I have
Cédric Champeau, also working with Louis, and we have a third member of the team who is not with us today, so Jendrik helped us prepare this webinar, so thanks to him.
Okay. So, as you've seen in the title, this is a part 2. Having seen part 1 is not mandatory to understand what we're going to discuss about. However, if you haven't seen part 1, I can only recommend you check it out because of the good content it has. The fact that Cedric and I did it has absolutely nothing to do with the fact that it's amazing content, actually. So what we will start doing today is actually a quick recap and also take a peek at some of the features that Gradle provide that we will use during this webinar. And so first, let's see again how we can declare and also analyze dependencies that are used in a Gradle build. So quick recap, Gradle is a build tool. The goal is to do automation and building of projects. It has a rich dependency management functionality. And it's JVM based, implemented in Java, completely open source. It's an Apache standard license 2.0. And of course, it's an agnostic build tool. So most of you may know it via the Java ecosystem, but it can build Groovy, Kotlin, Scala code. It's also the tool for Android, but it also has components in order to build native code. And here at the bottom of the screen, you see a short build script that will build a Java library pulling dependency from Maven Central, and we're using a logging API dependency. So one thing that comes with Gradle, which is outside of the open source build tool, is the ability to take a record of what a build did and view it via web UI. This is what's called build scans. And this is one of the key features of the Gradle Enterprise suite. So if you want to try out a build scan, you can simply add --scan with any recent Gradle version to your build. It will ask you a couple questions and upload the build to a public server, but the URL you will get will be private in the sense that it's not easily discoverable. However, you can share it with anyone, so you need to pay attention if your company or if your pet project is fine with these conditions. Of course, if you're interested, you can go to Gradle Enterprise, which is then a commercial product that can be installed on premise, and thus you don't have any security problems with that, effectively. I mean, confidentiality, sorry. And so here you see a screenshot of a Gradle build scan. We'll have opportunities during the webinar to use them and navigate some of the features that relate to dependency management in these build scans. So, quick recap. On the first webinar, we talked about the fact that Gradle fetches modules, so dependencies, from repositories. This is nowadays the most often used system. You can still have dependencies in a library folder. You can do also other ways of getting dependencies like composite builds or source dependencies, which we haven't covered in any of the webinars so far and probably will later. And most often on the JVM, a module, so a dependency, is a jar file and some metadata associated with it. There can be multiple jars sometimes, but most often it's a jar and it's a metadata file. And there is one thing that's important to understand is that the way Gradle interacts with repositories is in sequential order. We will see later in today's webinar why this has some importance. And if you remember the previous webinar, we also explained that it's linked to the reproducibility and the consistency that Gradle wants to provide for its users. So the first thing you can do is, of course, in order to leverage dependency management, you will declare a dependency, which by default will bring all the transitive dependencies. And so here, for example, we're using HTTP client in the implementation configuration. And when we look at the dependency graph, what we analyze is the compile class path dependency. If you don't understand the reason between implementation as the declaration source and compile class path as the resolved configuration, then I strongly recommend you have a look at the first webinar. But again, it should not impair your understanding of this content today. And so here, the Gradle dependencies is a command line task that all Gradle projects have, and it will show in the output of your terminal what's on the compile class path. And in this case, we see the HTTP client with the same version that we declared, and we see that it pulls 3 transitive dependencies. HTTP core, commons logging, commons codec. Commons logging is interesting. We'll talk about it later. Then we can also focus on a single dependency because, of course, the graph we showed you there is really small. Most projects, most applications will have a much larger graph, and sometimes the information you look for really depends on a specific, is on a specific dependency. And so what we can do here is use the dependency insight task, which is a more focused report task. We again say that it's from the compile class path, and then we look at the codec dependency. And we can see that that codec dependency is brought by HTTP client, which itself is brought by the compile class path. And so it's a reverted view compared to the previous three we looked at, where what you focus on and you see all the things that require it, all the way down to the top level compile class path in this case. Of course, via build scans, you have a similar tree view, so similar to dependencies, and also you can open pop-up for each component that will also give you the similar view to the dependency insight. So you get both ends in a single build scan. And so here you've got a screenshot that shows you a little bit. Again, we'll have demos during this webinar where we will see more about this content. So Gradle is not just about dependencies. One of the version 4 introduced dependency constraints. And this effectively is a way of saying if a module, a dependency, enters my graph, then I have something to say about its version. However, if nobody in the graph needs it, then I don't need it. One thing that sometimes confuses people is because of the name constraints, they believe that it will override the version of transitive dependencies. This is not the case. And so here you see, for example, I'm defining constraints on SLF4J API, commons long 3, and then when I'm adding my dependencies, I've just have SLF4J API without a version because the version is provided by the constraint. And if I was to run a dependencies or dependency insight report, I would not find commons length 3 in my graph because there is no concrete or hard edges, as we call them, to it. Gradle also allows you to define richer versions, which can be defined both on a dependency or on a constraint. And the idea is that you can say more about your opinion of a given dependency. And again, there is no override. It is just adding more information. And so here we see an example that the PicoCli dependency, which is a command line parsing tool, I strictly want a version in the 3.9 range. So from 3.9 up to 4.0 excluded. And if nobody has an opinion, then 3.9.5 is what I tested, most likely. And I also add a because, which will help people analyzing transitive graphs, further down the chain. If they use my library, which uses PicoCli, then they will understand that I'm depending on that because I've got a part of my tool, which is command line parsing. That's also content from the first webinar. So again, if that's of interest for you, go back there. We will also explain more of the usage of platforms in today's webinar. So a platform effectively is a way. It's a plugin that Gradle introduced in one of the recent 5x version, and it allows you to define a project that does not contain any source. However, it contains information about dependencies, and mostly it is a source of constraints. So here, I'm effectively saying that my projects should use SLF4J API 1726. My project's runtime parts should use SLF4J simple 1726. So again, the API for the logging framework and one of its implementations. And then what happens is that one of my projects, the CLI projects, in its build file, depends on the platform by doing that API platform project platform notation, and then can say, I want the implementation, I want the dependency SLF4J API as an implementation dependency without specifying a version. And the version is actually provided by the platform. And so here we see one of the features of the constraints, which is their transitive aspect. So in conclusion for this introduction, really what matters for Gradle is the semantics. When you're depending on a number of libraries, there are good reasons for that. When you're conflict resolving, when you're manipulating the dependency graph. There are strong reasons for that. When you depend on a third party for compilation versus for at runtime, it means something. When you define a library and that library exports some compile time dependency versus a different set as runtime dependencies, you're also stating something. And Gradle really believes that this semantic is really important and is key to having an ecosystem that can work and be combined by its users. So we will now move on to understanding conflict resolution, and that's for you, Cedric.
Yes, so now we all live in a more complex world than the one we described in the previous webinar. So we kind of lived in the ideal world in the previous one. So we said, yeah, we have dependencies, everything works exactly as I expect. I say I depend on this version and what I get is exactly this version. This never happens in the real world, right? So we enter the world of conflict resolution. So actually something super important to say is that there is not just one kind of conflict in the real world. So the one we see most often is often just the version conflicts. So you say you depend on one and you get a different version of a dependency. But there are other kinds of conflicts which are equally important and maybe even more sneaky somehow. It is the implementation conflicts. So this is typically when you have different libraries on your class path and they don't work together or they conflict with each other. So there is some kind of mutual exclusivity between the features and you have to choose one implementation over the other. And one of the goals of the dependency management team is to make those use cases easier to fix in the long run. So first, version conflict is actually something quite simple. So you get two dependencies, they depend on the same module, and it can be either a direct dependency or a transitive dependency. So you have A that depends on D11, B on D10, and what you get is conflict resolution going on. We would select 1-1. But in the real world, what you would get is something like that, and we would like to explain the differences between Maven and Gradle in dependency resolution and in conflict resolution, because this is basically a question we get often. Why does Gradle doesn't resolve the same as Maven? So often our answer is to say we don't want to reproduce the same bugs. So this is our explanation to this. So take this graph. I have a root project that depends on Guava 20. And also on Juice 4.2.2, which is a real dependency that you can find on Maven Central. And Juice actually also depends on Guava, and Maven would select version 20. We would select version 25.1. So it is interesting to understand why we make that decision. So Maven is actually doing something that we call the nearest first strategy. And what it means is that the nearest dependency you find is going to win, which at first glance sounds quite reasonable. I mean, you take a decision, you say, I depend on Guava 20, so yeah, this is the version I should use. So the root has a direct dependency to Guava. Guava says 20, so yeah, Maven is going to select 20. Should be fine, right? Well, maybe not. What are the problems with that? So let's take a different dependency graph, and this time we have two dependencies, but we can see that the Guava one is not a direct dependency. So Guava is actually always a second level dependency here. So the first one is Juice that we still use, and the second one is a different library, which is Reflections, and also brings Guava. So in this case, Maven would select 25.1. So already we see something strange, right? So it was selecting Guava 20 in the first version, but now it selects a different version just because it's not at the same depth in the graph. So, okay, but still makes sense. Yeah, this is the first one that we see, so it is closer in the graph somehow. Okay, but now, what if I revert the two dependencies and decide that now I depend on Reflections first and then on juice. Well, what happens is that actually Maven would resolve 20 this time. So just by changing the order of the dependencies in the graph, what happens is that we select a different version.
And when you mean order, you mean the order in the build file?
I mean the order in the POM file, yes. And as you know, Maven uses the same file for building and publishing, so all kind of problems come from that. But basically, this is a super simple example with just 2 dependencies, but it means that if you have a real-world dependency graph with a lot of dependencies, you cannot predict whatever version is going to be resolved for transitive dependencies. The only thing that you can predict is the first level dependencies, nothing more, which is a bit annoying. So Gradle doesn't take that, it chooses a different strategy. So usually what people do in Maven to work around the fact that you have to add a first level dependency is either add exclusions and then define a dependency at the first level, which is using the version you want, but then you introduce all kinds of problems like leaking dependencies on the compile class path or whatever. Or they use what they call the dependency management block, which is interesting and has some benefits, but it has a major drawback, which is that it is not transitive. And it has consequences during the resolution. So Gradle actually does something different. We do what we call full conflict resolution. So whatever you have in the graph, we say, if someone says it depends on Guava 25, it means something. It means that at some point someone decided this is the version I need. So there's no reason to exclude this information from the graph resolution. We should take that information into consideration when selecting. So we use a simple strategy by default, highest wins. So this is kind of intuitive in the world we live. This is basically the assumption that whatever is higher works. This is obviously not always true. If you follow semantic versioning, you would know that you're not allowed to jump from version 2 to version 3 because you can have some breaking changes. But in the real world, this kind of works. Okay, so Gradle is going to do the whole dependency graph resolution and select something.
Yeah, and just to be clear, we've shown again like the rich version declaration which had strictly. In that context, highest wins means the highest that's acceptable by the strictly.
Yes.
And if different strictly disagrees, then you get a failure and you have to resolve it. So it's not just highest squashes everything. It's highest in the context of your version declarations.
Yeah. What matters is what you declare, and then the tool is responsible for making sense of every information it gets. Constraints, version declarations, whatever. Okay, so speaking of dependency constraints, this is the big difference with the dependency management block of Maven. This is transitive. So it means that the constraint that is here is going to be taken into account as soon as it appears in the graph, somewhere in the graph. Just some words about Ivy, because some customers of us actually use Ivy. So Ivy is a bit more complex than Maven in that regard, because it has pluggable conflict resolution strategies, and what it does is whatever you declare in the build file, so it's actually very hard to predict what is going to happen with Ivy. So how do we handle conflict resolution with Gradle? One thing that you can do to help is actually first thing, realize that you have some conflicts going on. And this is some strategy that lots of projects are actually using, and it means that as soon as you have a version conflict, wherever it is in the graph, you want to be aware of it. So you just do resolution strategy fail on version conflict, and then the build is going to fail if you have one. It says exactly what it says. So this is nice, but then it means that you have to find a solution to the failure, and we're going to discuss the solutions. The solution, the most obvious one, is to use what we call a dependency resolution rule, and it means you have a conflict between commands lang 3.1 and commands lang 3.3.1. Well, you look at the two versions and you select which one you prefer. And in this case, we say, yeah, I'm going to use 3.3.1, and because I'm nice, I'm going to add a little description that says, I tested with this version and it actually works. So this is some very simple way to fix the build failures that you would get by activating this fail on version conflict flag. So this is just a simple project. As you can see, it doesn't have many dependencies, 4 dependencies and 3 test dependencies. So I'm using Camel CDI, Spark Core, Ivy, and of course we all use loggers. So I'm using SLF4J API. And for testing JUnit, HTML unit, and I want to use this SLF4J simple logger binding just for resolution, right? So this project has a test. So what I'm going to do is to run this test. So going to the terminal and run test. This is going to build. And at the end of the build, I'm going to have a build scan. So everything went fine. So yeah, we don't need that webinar anymore. Maybe not. So let's look at the test report for this guy. Test. Okay, so I have one test class, and here I get this strange logging error that you all have seen sometime if you do some Java programming. You have multiple bindings of SLF4J on the class path, and the build tool didn't tell us. And you blame us because, well, you should have explained us that actually there is a problem there, right? This is what you would say. Okay, so we have a problem. Let's see what the problem is. So if I go to my build scan, I can actually open this guy. And, oops, it's not opening, is it? Can't click, yeah. So this is the build scan for this build. What I'm interested in is going into the dependencies block there. And we're going to explore and see that for test, what we resolved is the test compile class path and test runtime class path. Because we executed the test, I'm going to look at the test runtime class path. We have many things to say in this webinar, but let's focus on the test runtime class path. And if we look at this, what we see is all the resolved dependencies for this simple project. And it's actually already quite important. We can see already that there is a conflict resolution going on for Ivy, but I'm pretty sure that if I open other dependencies like Spark, I'm going to find more conflicts at some point. Yeah, Jackson is upgraded, whatever. So we already have some conflict resolution going on. And well, this is where the fun starts. So now I want to understand why I have all those bindings on my class path. So I'm going to run the command that we talked about in the intro, which is Gradle dependencies. And this one is just going to dump on the command line all the dependencies that you have on this project. So you can see that already for this simple project, the report is huge. So something to mention is that even if you don't use build scans, you have tools on the command line to do this. But it's hard to read. However, I have some information. I know that from the build scans, I know that I resolved the compile class path and the runtime class path. So I want to focus on the test runtime class path. So what I'm going to do is actually add a flag there, say, please focus on this configuration test runtime class path. And then the report is going to be shorter, but still shows a lot there. Okay? So this is all the dependencies that I have resolved. So I'm going to switch to the build scan again, just to show you something nice. So the scrolling through this terminal was a bit hard, but if I go to the build scan factory, I have the full output there. So I can see this report in the build scan too, which is pretty nice, I think. So you can get all the output there, and then you can look more precisely at what is going on in this dependencies view. And because the dependencies report only focused on the test runtime class path, I can work in this tree, and it's harder for me to figure out what is going on. So we have multiple bindings, so I'm going to do a simple search with slf4j, and what it shows me already is I have lots of different things there. So I can see a dependency on JCL, which is commands logging over slf4j, Java util logging to slf4j, which is a bridge again. We have all those slf4j API, that's okay. slf4j, log4j, which is actually using slf4j and log4j as the implementation for logging. And the one that actually I wanted, which is slf4j simple, is there. So probably my problem comes from having both log4j and simple, which is something that the message actually told me in the test report. Something interesting is that actually if I search for log, I will also notice that I have this commands logging coming from somewhere. And if I open this and look at the required by, I can see that commands logging is brought by HTTP client. So something we wanted to mention too is that none of this should be necessary at the compile time, but because those things are, the metadata of those components is broken, it says that it needs them at compile time when it needs them at runtime, it appears in the graph. So we could fix them, but I'm going to use a simple example to illustrate how you can fix all those problems.
Yeah. And as you can see, in addition to commands logging, you also have the log4j implementation.
Yes.
So
it's all the possible mess, just 4 dependencies, and you have all possible loggers on the class path. Yeah. Which is nice, right? At least we can log something. So, the first step is, can I detect that before actually running my test? So can I make the build fail if this happens, if I have multiple versions of loggers on the class path? And the answer is yes. So I'm going to add detect logger conflicts there, and then go back to my terminal window. Where is this? And I'm going to do a dependency insight report this time. So if you remember what Louis talked about, dependency insight is about focusing on one dependency. So I'm going to focus on configuration test runtime class path. And I want to see what happens with my slf4j simple dependency. So I just added this line, detect logger conflicts, and now I run this guy. And now the build fails, which is quite nice, right? Well, the dependency insight report fails. And what it tells me is that I cannot select slf4j simple because actually something else in the graph is providing the same capability. So we're starting to introduce a concept, which is the capability, and this means you have 2 things on the class path that provide the same thing. You should choose. So already detection. So just to make sure everything is okay, if I run Gradle test, I want this to fail too. So I'm just going to check that it fails. And it does. So now, before my build was not failing, now I can't even compile. It fails before compiling. So let's go back to this build scan and see what is going on. When I run the dependency insight report, it tells me I have 6 dependencies failing and slf4j simple is one of them. So this is cool, but I made my situation and my life harder, right? Because I just didn't have any build failure before, and you just made my build fail.
Well, you had runtime failures. Well, not technically a failure,
okay.
But you had at least a runtime warning, and in that case, you could live with it. but there are probably situations where it could be
Okay.
a late detection.
So before, I'm going to show you what is the magic behind that.
But there is no magic, only science, like I said.
So this is how I detected the conflict. Let's zoom a bit. So we have, this is the Kotlin DSL. So this is Kotlin code. What this is basically doing is enhancing the dependency handler and adding, registering some rules, right? So I'm just saying, with this module, so this module, JSON over SLF4J actually provides the same capability as commands logging. And SLF4J simple provides an implementation of SLF4J, etc., etc. So I can enhance the metadata of components which I don't own, which is the point here. The authors of those libraries should tell us that they are not compatible. But because they don't, Gradle offers you a way to enhance metadata. So in the future, if they actually use the features that we're talking about today and provide this metadata out of the box, we wouldn't need those rules, but you can add them, which is interesting. So the idea today is not to focus on what this and how to introduce that. We have the documentation to explain this, but to understand that it is possible to enhance metadata. And now I want to fix this. And to fix that, I'm just going to use this configurations block, configurations, and say, when I'm going to resolve, actually what I want to do is to prefer SLF4J simple, right? So I have again a method there that says, yeah, let's prefer SLF4J simple. And I'm going to run Gradle test again. Oops, still have a problem. What is the problem here? Is that actually I prefer SLF4J simple, but I also realize that I have this commands logging dependency that is conflicting with the one I want to use, which is JCL over SLF4J. So yeah, SLF4J provides its own implementations of commands logging, and this is the one I want to use. I don't want to use the real commands logging implementation. I want to use the one provided by SLF4J, and I detected that too with my capabilities rules. So I need something else. I need to explain how to prefer this one too. So let's add again a method there, and I'm going to say, actually, I use SLF4J everywhere. And this is going to be interesting, because now, if I come back and run my tests, the MacBook is overheating. The temperature is what? 35 degrees
Celsius? Yeah. No, it's down to 33.
33, okay. So if you see us sweating, this is because of this. And now my test is passing. So I'm back to my initial situation, but I have kind of improved the situation,
Can
right?
we check your output, just to be sure? Because it passed the first time, right?
You want me to check? Okay. You don't trust me.
Yeah.
Okay, let's go to the test results and refresh this guy. And look at the standard error. Oh, it works. So now I have fixed the conflicts.
Yeah.
But again, I didn't explain how I did that, right?
That's true.
Okay, so you want more explanations. So what are those two methods doing? So those are not methods provided by Gradle. Let's be very clear about that. This is methods that I added in my own build that make it more sensible what I'm actually doing. So I chose as the build author to prefer SLF4J simple. And I chose as the build author to use SLF4J everywhere. So replace all the different implementations with the one from SLF4J. And how I do that is actually pretty simple. It's using something that we call substitution rules. And this is a super powerful tool in dependency resolution in Gradle. Dependency substitution means replace this one with this other. This is exactly what it says. And it says substitute SLF4J log4j with SLF4J simple. So somewhere in my dependency graph, someone actually wanted to use log4j as the binding. I wanted to use simple, so I just replace it. And now everybody agrees that we should use simple. Similarly, we had this log4j dependency coming, and we know that we don't need log4j anymore, right? So we can substitute it with the bridge. And for SL4j everywhere, it's actually quite simple, it's quite similar. This time we talk about commands logging, and we decided to replace it with the binding from SL4j. So the magic is just called dependency substitution. So replace something with something else. So it is quite powerful. You can do substitution with binary dependencies, or you can do substitution with project dependencies, and you can even do what we call composite builds, which is something we're going to discuss in a different webinar. All right, so let's go into a different kind of conflict, because we solved a pretty hard one, which is the logger conflict that everybody has, but we have more kinds of conflicts. So I'm going to open the build scan for my last passing build and see what other kind of conflicts this has. So I'm going back to the test runtime class path, and if I open this camel CDI dependency, I can see something which is strange there. There is a dependency on delta spike, and no way I use this, right? Actually, if you search Google for this and camel core, you would find an issue on the camel project that says, hey, actually delta spike should have been an optional dependency. So there is no reason for me to download it. I will not use it, and it should have been an optional dependency because only people using delta spike should get this guy. And everybody is getting it. So I want to get rid of this. So what is interesting is that what most people would think is, let's exclude this dependency, right? And this is what a Maven build author would do, because this is the only tool available at hand. But the reality is that this is not really an exclusion there. This is actually needed if you have delta spike, but this is just wrong metadata, right? What is published on Maven Central is wrong. This should have been an optional dependency. So we can fix that. And the semantics around this is different from an exclude, because what we want to do is to fix bad metadata. So again, I added something in the dependencies block, a method of mine, which I called fix bad metadata for my context. And if I run my build again and look at the build scan at the end of this build, I should already see a difference. So dependencies, I go to the runtime class path, and if I open Spark core, well, delta spike has gone. So that's pretty cool. I'm going to show you one.
It was camel though. It's gone, but
oh, sorry. It was you're saying that I'm I'm cheating.
Yeah, but it's still gone, right?
You know, I could have made it my life easier to figure out what the difference are.
Yeah.
So I'm going to use a feature of build scans, which is comparison. So I'm going to take this build. So the first one before I called the fix bad metadata method, and now I'm going to look at my other builds, demo, conflict, live, conflicts, sorry, live, and the previous one that I executed is this one. So I'm selecting two different builds, and now I'm going to click on compare, and this is going to tell me something interesting. I have differences there. If I go to the dependencies, I can see that the one on the left had those dependencies that disappeared now. So I can compare two builds, and it's going to tell me what the differences are, which is quite nice, especially for this kind of dependency debugging issues. All right, so now, how did I do the magic again? Well, no magic. It's just what we call a component metadata rule. And what does it do? For all the components that I'm going to resolve, for this camel CDI project, which is actually the module that is broken, that has bad metadata on central, I'm going to apply this fixed camel rule. And what it does is, if I'm actually working on the 2.15 version, which is the broken one, I can say for all variants of this, remove this delta spike dependency. It shouldn't be there. And it's not my opinion. The camel people are saying that it shouldn't be there. So this is an important thing to realize. So it's not an exclusion, it's really something broken for everybody. Okay. If we come back to our initial build, there is still one thing I want to fix. I have this IV dependency which has been upgraded to 2.4, and I'm a bit annoyed because I know that 2.4 doesn't work for me really. I know that it works for 2.3 and I don't want it to be graded to 2.4. So I need to understand where this 2.4 is coming from. So here it's just saying that the test runtime class path is including IV, but I need to find it in my dependency graph and find where it comes from. And I have two paths, and this guy is actually bringing the 2.4 version. So I can click on it and it tells me Spark core is actually depending on IV. Again, I have something special because I know that, well, for the features of Spark that I'm using, I'm actually not using the IV part of Spark. I don't care about this. So Spark has a need for IV, but for the cut path that I'm going to use, this should never be triggered, right? So this is actually a valid use case for an exclude, but I want to give more semantics around that. I just don't want to just add exclude, which doesn't carry enough information for the engine to realize what we need to do. So here, I know that now the dependency is coming from Spark core, so I'm going to add something that says without a feature of Spark which requires org Apache IV. Okay, so here I'm saying I need Spark core, but I'm not using the part of Spark core that actually needs IV. And I made it clear that my intent is not excluding because Spark really needs it. But I'm saying something more. And if I run test again, or just dependency insight, configuration, test runtime class path, and then look at this IV dependency, I wish that now actually I'm bringing to 3 and not to 4. And this is exactly what is happening. Interestingly, if I go to my dependency insight report and look for Spark core, I will get interesting information there. So the dependency insight is telling me we don't use the features of Spark core which require Apache IV. So how did I do that? So again, I need to come to this method and look at what it does. And it's quite simple. It's actually excluding IV, but it gives a reason. So this because that you talked about and that we discussed in the first webinar is actually in use there. So, okay, I'm excluding something because at some point, this is the only tool that you have. I'm excluding, but I'm making sense of the exclude. And our goal in dependency management is slowly improving all those use cases to make sense of them so that the engine is better at making decisions. And an exclusion, because you don't require this specific feature, is something that the engine needs to know in order to take better decisions in case of conflicts. That's it for the demo. We can come back to the slides. So when metadata is wrong, you should use a component metadata rule. So component metadata rule allows you to fix metadata, and this is applied to all configurations being resolved. So this is important to notice that every configuration is going to do that. So the scope is really what is universally true about a dependency.
In your build or in your
build or whatever,
if you share them. But
and the example was this. So the delta spike one, and we fixed it thanks to this component metadata rule. The second one is actually the logger use case, where you actually have multiple implementations of the same thing on the class path and you want to use one of them only. And this is what we call mutual exclusivity, and this is solved by capabilities. So relocation of libraries is actually something similar that we didn't discuss, but it's worth mentioning. So typically you can have ASM, which was once published at ASM and is now published at a different coordinates, but it's actually the same library. It provides the same capability. So again, this is about capabilities, and capabilities can fix this by upgrading capabilities to a newer version. Detection of conflicts wasn't automatic. Ideally, we would have a plugin, and we are actually working on this. So a plugin that would understand all this mess around logging frameworks in the Java ecosystem and do that for you. It would be opt-in because we don't want to break all the builds of everybody just because, well, sometimes you don't care having multiple loggers, just run tests and whatever. But sometimes it's really annoying when you lose some messages just because you don't use the same logger. So detecting conflicts, selection of, well, fixing the conflicts is done through what we call component rules, and it uses dependency substitution, which effectively replaces one module with another. And now I'm going to hand it over to Louis to explain a bit more what are excludes and why we think this is not necessarily the best solution.
Just as a quick wrap up on what Cedric said on the previous slide, we were using the Kotlin DSL, which enables us to do extension methods. All of the features you've seen are perfectly supported in Groovy.
Yes.
It's just that the way you would put them in practice would be slightly different because of not an extension method, but a Groovy closure that applies to the context or something like that. So, but all of that is perfectly available with both. And actually, all of the Gradle samples in the user guide have a Groovy and a Kotlin equivalence. So you can clearly go over that. So Cedric mentioned that exclude aspect. Well, exclude is interesting because there again, it's a tool, right? A consumer can prune part of a transitive graph. However, again, we get questions, why does Gradle behave that way? Because Maven does it differently. Well, again...
The question is more like, do it like Maven.
Well, yeah, usually it's during a migration or something, so there is a problem there. But once again, the fact that Gradle does it differently is also, again, with a similar similar conceptual difference than what we see with version conflict. So in the Maven case, if I have a root project that brings in B as a dependency, but tells the B it brings that C shouldn't be brought in, and then as another dependency E that brings itself B and C, the result for Maven is that C is excluded. And it comes again from that nearest first approach, because effectively once we've seen B, we've seen the B that carried the exclude, and so C won't be taken into account. In the Gradle use case, in order to have the same effect, you have to actually put the exclude both on B and E. And that's because the same way Gradle says all version information is important, Gradle says all transitive information is important. And so maybe you use B and not require C, but does that mean that E does not use B in a way that requires C? Can't say that. And so what Gradle says is, well, if you don't tell me that path doesn't require it, I consider it's important, and so I bring it in. And here you see that you've got to exclude it on both edges, and then you get the right result, the expected result if you really don't want C at all. There is another option for Gradle, which is the configuration level exclude. So pretty much when a dependency appears many times and deep into the dependency graph, and you really don't need it, you just want to say once and for all, I don't need it. And I'm using common slugging here as an example. Common slugging is a library that's been around for a long time. And when it was designed, it didn't have an API versus implementation separation. And so anyone that wanted to use common slugging was effectively also bringing the implementation side. And we've seen that SLF4J offers another implementation for the API. So nowadays we can have that kind of conflicts. And so here what I'm saying is effectively on all the configurations, I never want common slugging. Two things that you need to know, however, about that configuration level exclude. The first one, it will leak to your downstream consumers. And the way Gradle does that, and Gradle does it because if you do that between two projects, that information carries over. And so it will also do it at publication time. However, at publication time, the metadata format that we have, the Maven one, or even the upcoming Gradle metadata format, only tells things about dependencies. Well, it tells more, but the dependency, the part of the graph is really focused on the first level dependencies. And so what Gradle will do, it will distribute that exclusion to all the first level dependencies you have. So if it's really your use case, think about it before doing so in a library that others can consume. And so that's really the message around excludes. They should be a last resort situation. The real semantics should be what Cedric explained with that Spark Ivy relationship. My usage of Spark does not require the Ivy dependency. Does that mean maybe it should have been an optional dependency? Well, you'll have to look at the Spark code and understand how they structure the library and everything. And the goal here is not to discuss that, whether they were right or wrong. The thing is, you found a way to use Spark that does not require Ivy. An exclude could be an expression of that right now. And so here we see again the code that Cedric showed in his demo. So we've talked about a number of concepts. One more concept that we see often used and potentially abused that Gradle offers is the forcing. So again, forcing, ideally don't. For once, this is one of the rare occasions in Gradle where it is somewhat order dependent. So if a plugin applies the force and you also declare a competing force on the same dependency in your build script, if you end up applying the plugin after your build script dependencies are added, then the build script dependency will win. Otherwise, it might be the plugin that wins. I mean, there is a bit of a race in there, which is not safe. Also, force will not be transitive. Only Ivy has that concept in its metadata. But for Maven or Gradle module metadata, it does not. It's not communicated. So instead, you should do what Cedric demoed, which is the resolution rules, where you say, oh, I always want, I think it was commons length 3, or yes. I don't, and you always want 331, that version, nothing else. The last thing you've got to play, that you can play with, is actually disabling the transitive aspect of resolution. Sometimes you really don't care about transitivity. And here, for example, what we see is what I need is downloading a set of files. It's not downloading a dependency graph, it's just downloading files. And so I can create a custom configuration for that, which I set transitive equal false. And then when I look at the downloaded files, it will only download the first level things that I declare in it. Transitive dependencies as a way of fixing the conflicts in your, like playing around with the transitive aspect of a configuration or a dependency as a way of fixing conflict is also usually not really what you want to do. And if you care about the semantics, you should try something else. However, here in that context, this is perfect semantic. I just want the first level files, nothing else. I'm just disabling transitive resolution. So what's really important to understand is that when you handle version conflict, it can have consequences. Gradle users fall into two broad categories, and most of you will be actually in both of these categories. The first category is library author, because these people provide a software component that they expect to be reused. It can be a public software component, like an open source library, open to the whole community for usage. It can be a company internal utility library that some of the internal applications of the company will use. Both have their use, of course. And the other hand is application developers. These sit at the end of the chain. And somehow, yeah.
You can be an application author and still live in a multi-module build or multi-project build, and you have both the application and libraries sitting next to each other.
Yeah. And so what happens is that for an application developer, well, it's pretty much open bar. I mean, in the end, if what works for you and is faster is a combination of excludes and force, nobody will consume your metadata, the metadata of your project. However, when you're a library author, you need to think about what happens for the rest of the chain. Like if I exclude, what happens to my consumer? If I force, what I resolved will not be what my consumer resolved because they won't get the force information. On the same time, if I add a constraint, that they will see. If I use a range, will they actually resolve exactly what I tested? So there is here a need of understanding some of these consequences. And so this is really something, it goes back to that last slide of the first section where we said semantics matter. They really matter, and so think about it, help the community when you publish something by having metadata that's properly crafted so that others can then use it and leverage it to the maximum.
And the more semantic we add in Gradle, the easier it is for it to take a good decision.
Yeah. And so that leads us to the next section, which is going a little bit higher. We're no longer talking about inter-modules conflict, but looking at the graph consistency in itself. Cedric, shoot.
So what is the challenge here? So as you said, we're going a level up and we're working at the, say, the company level. So something we see is that the dependencies that you get in the transitive graph actually do not work in isolation, right? That's because you depend on something that depends on something, and you can have interactions between all those components. Sometimes you have projects like the typical Jackson JSON library, which has different modules, and you bring in one module, you bring another one, and you want to make sure that they actually work well together, but they belong to the same unit, which is Jackson. So there is more than just version conflict around just one single dependency. There is also a concept around a group of dependencies, and you want to say something about this group. And as an organization, there are different ways you can influence the resolution, and we see that in the wild. So one is just saying, as a company, we actually tested all those libraries and we say this one is correct, this one is not, this one is correct, please use this. And if you have no opinion, you should use this version. So this is kind of recommendations around the versions of the different modules that you want to use. A second aspect is the ability to control where a dependency comes from, and we'll see why it is important too. So we have different options to solve all those issues. So regarding the origin of the dependency, we have something new in Gradle 4.5, if I'm not mistaken, which is called repository content filtering. Regarding recommendations, we have support for the Maven bill of materials and of course the Java platform plugin in Gradle. You're going to talk about alignment, and we have more, but not really all the time today to discuss about all the different options. I'm going to mention the first one, which is around repository content filtering, and behind this weird name is actually something pretty simple. This is about this slide that we had in the beginning, which says modules come from different repositories. And it can happen that in two different repositories, two different public repositories, you actually don't have the same binary. Or you can have different metadata for the same component. So sometimes this is just not intentional, like people start building and publish on Maven Central and then say, oh, it would be cool to have this on JCenter. So they rebuild, and because they don't use Gradle, they have a different binary in the end. They publish on Central, they publish on JCenter, and JCenter has a different artifact with a different timestamp or whatever. So this is one use case, but sometimes it is much worse.
Yep.
You can have someone publishing a compromised dependency, so intentionally taking place of a dependency and just to be able to sneak into your software and do bad things. So this is important for security. So we have a feature that lets you declare what the different repositories contain. So let's say that my organization publishes components that are under the my.company group, and I'm pretty sure those shouldn't be found on Maven Central, right? So I'm going to use this block, the include by regex, which is something interesting to tell. For this Maven repository, which is actually local to my company, you will only find components from my company and nothing else. So it's not worth checking different dependencies. You won't find them. So it's good for performance because it's going to be faster. And it's also good for security because I'm putting this one first. So I know that if Gradle finds something with my.company, it is only going to be found in this one. Actually, you can really make sure that it is not going to be found in the second one by excluding it in the second one. So JCenter says, I don't want to find SLF4J from JCenter because, I don't know, maybe it has been compromised there. And you know that it has been compromised too, so you don't want to find it from this repository. And you're sure that you're not going to find my company artifacts there. So because ordering is important, it has an impact on performance because you're going to look at the repositories in sequence, and it is extremely important for security because the order matters. So by combining those includes and excludes, you can really tweak where a dependency is going to be found.
And so just to, because I think you said it was version 4 something, but it's actually in 5, and I think it's 5.1 when repository content filtering appeared. But again, that's for people looking if they have the right Gradle version. So let's move on to the bill of materials support. So a quick recap, that's a concept coming from the Maven metadata. It's mostly used for defining versions of dependencies. In the Maven world, it actually also allows you to define version and even shared configuration of plugins. But here in this context, and in the way Gradle consumes it, we're limiting it to the version of dependencies. And usually when a project produces a BOM, it's because they're stating that they have a consistent set of versions that work together. Whether it's the Jackson BOM, which comes with each Jackson release and says, here are all the versions of the Jackson components that work together, or it's for a wider ecosystem like the Spring ecosystem, where you've got, for example, the Spring Boot dependencies BOM, which effectively states what are the Spring components, but also the third party, like third party from Spring components that work together. And the idea is that you consume the BOM, then declare dependencies you use, and it works just like Gradle's dependencies and constraints. The BOM provides the constraints, and the build file only declares the dependencies without versions. So the way it works in Gradle is by wrapping that coordinates of a dependency inside that platform keyword. This plays effectively with the attributes underneath. If you've got no idea what I'm talking about, this is again a hint for learning something in the first webinar. But so effectively, this is the way you get the platform part of the BOM. So you import all the constraints. There are particularities in Gradle. Once again, this is not just because we want to be different than Maven, it's because Gradle went down a path with some consistency decisions, and Maven went down another path, and so differences result. I don't think one is completely perfect versus the other completely wrong. That's not the discussion, but the differences are important when you migrate from one to the other. So the dependency declarations from the BOM will be imported as constraints, which means they also become transitive. The BOMs are like regular dependencies. They can be visible, their constraints are visible, So if your project, like a Java library plugin project, declares a BOM in its API configuration, consumers will have the BOM as part of their dependencies. Gradle keeps looking at all the versions in the dependency graph. It will always do that. The main difference that results from that is that in Gradle, the transitive dependency graph can still resolve a dependency with a different version than the BOM. Remember, we do not make nearest win. We conflict resolve every version. So that's important to know. Of course, when we announced that we were supporting BOM, that was one of the first feedback we got. And we understood that we could probably help the migration path. And so the way you can simplify some of the migration is by using the enforced platform concept. What it does is it effectively applies all of the constraints from the BOM as forces. Like we've said earlier, forces are not strongly recommended, and especially because they're like a hammer. I mean, they freeze the version and they have some ordering issues. However, you need to understand that if you apply forces through an enforced platform, it actually becomes transitive because that's information which is carried over transitively to your consumer. So clearly, if you have consumer, you should not use it. If you're an application developer, that's a perfectly legal way of having a dependency resolution, which in 90% of the use cases is going to be the same as the Maven one. So one thing that you can do with the BOM support in Gradle is you can start removing some of third-party plugins that were developed in the past, inspired that feature actually, but had, again, some differences. So if you want to replace the Spring Dependency Management plugin, it's going to be okay for most use cases. What's not going to work is the Spring Dependency Management plugin has a feature when you can override properties found in the BOM so that you actually change the version of a set of dependencies. This works in Maven only if you have the Spring Boot as a parent BOM. It doesn't if you import it. In Gradle, with the BOM support, it won't work at all. And the second one is the Spring Dependency Management plugin will first look at your local dependencies and consider these to be of higher priority than what the BOM defines, which again replicates the Maven nearest first behavior. Once again, that will not work. So these are the two main scenarios that will cause differences if you move from Spring Dependency Management plugin to the native BOM support of Gradle 5.0. What you can do as well in Gradle is you can actually create your own recommendation BOMs. So similar to the Spring one. You would use the Java Platform plugin. The full features, however, requires the Gradle module metadata publication because when we do the mapping to a Maven BOM, some of the information is lost. What's important if you intend to use a Java Platform plugin to create such a BOM and then make it a Maven BOM to be published and consumed by Maven users, order matters a whole lot in Maven, as we've discussed. Because the order matters, it suddenly means that the order matters in your Gradle build file. It doesn't matter for Gradle or Gradle consumers, but it does matter for your Maven consumers. So here is an example. And here what I do is, and I'm starting from the bottom, which is what matters for Maven. I'm using Spring Boot dependencies. However, I want to bump the Jackson version. And so here I'm importing the Jackson BOM. And then I'm also saying that, by the way, that PostgreSQL version also needs a bump. And the reason I've declared these in that order is because that's the order they will appear in the Maven BOM that's published if I publish this. And that's the order in which Maven will respect them, because Maven will look at nearest first seen. So it will see Postgres first, then it will see Jackson, then it will see the Spring Boot things, which will have an opinion on both Jackson and Postgres, but that will have been overwritten. In a Gradle sense, this works because I'm doing upgrades. I mean, that's the problem you've seen with what we've discussed so far, is the downgrade scenario remains not always easy in Gradle. As mentioned, we've mentioned alignment a couple of times already in the discussion, but let's quickly recap the problem. You've got a group of dependencies designed to work together. Jackson, or even the Spring framework, like Spring Core, Spring Context, Spring Beans, all of these. when you've got a large dependency graph, through some of the transitive updates, a Jackson module here and a Jackson module there end up on different versions. Does that work? Maybe, maybe no. Do you want to spend time figuring it out if it works in all cases? Most likely not. The goal would be to say, well, if Jackson gets upgraded here, can you please upgrade Jackson there? Because then I've got a consistent view of Jackson, and hopefully I get better feedback of the users of Jackson telling me that don't work, instead of having to figure out if internals of Jackson may break on special code paths compared to others. So let's do a quick demo to illustrate what Gradle offers you to support that kind of use cases. So here we're looking at a very simple project. We've got a set of dependencies which are basic. So we're using the JSON data format YAML, we're using Vertex, and we've got a test dependency that's not relevant here. What we do with JSON data format YAML is we're saying, well, ideally, you know, in my previous project, I used 289. So I know it, I know what it does, let's use that. Vertex is 353 because maybe that's what my colleagues were using, and that's what we start with. And so what I'm going to look at now is, again, I'm going to use the dependencies report, and I'm going to look at the compile class path and see what's brought in. And so what we can see quickly is that my JSON data format YAML, no problem, 289. However, it requires core, which was upgraded from 289 to 295. Why is that? We scroll to the bottom. You could do that, of course, in a larger graph by using dependency inside, but for the sake of speed, I'm doing it by scrolling. And you see that it looks like Vertex uses Jackson Jackson core directly, which in version 295. And so we get a number of the Jackson items in version 295. Of course, my first reaction can be to go here and say, oh, let's align, right? And if I do that, no, I don't want to upgrade a Kotlin plugin in the middle of a demo. And if I do that, well then, obviously everything works. And I'm good, right? Job's done.
Cool.
Thank you. Now, of course, it's not that easy, and that's what we want to show you, because one day you'll decide to upgrade Vertex to version 371. And so you come back here again, issue the same command, and you're like, oh, 298? Wait, what does that mean? Oh, of course. Now I've got YAML 295, which gets a core 298. The chances are better that it still works, but do I really want to take the risk? And maybe I should go with the bomb that you talked about. Okay, we can try.
Production first.
Yeah, we can try with bombs, right? So I'm using the come faster XML, Jackson bomb, and I want 295. Because after all, that's what I want. So I can get rid of the version here. And that's what I want. I want 295. Oh, I get 298 still. Wait, what's happening? Well, effectively, I'm getting the bomb in 295, but I see that a number of the constraints, like not YAML, for example, but the others were upgraded. And the reason they're upgraded, it's because of that decision Gradle makes of considering all of the versions that enter the graph. So that doesn't work. Okay, let's use then a real Gradle feature that's going to make that work. What we're going to do is, similarly to what we did in the previous demo, we're going to create a component metadata rule which is going to align the Jackson versions. I'm implementing that method. I actually can replace that with running a closure against the details, which is a field of my component metadata context. And here what I do is that if my group, starts with, I'm just using strings, with come faster XML Jackson.
So this is the group of a dependency
Yeah.
that appears in a graph.
Yes, exactly. This is the group of a dependency. So it's again a component metadata rule. It will apply everywhere in my project. And here I'm using the feature which is called belongs to. And what belongs to allows me to do is it creates a virtual platform which then Gradle will leverage to perform the alignment. So this is a custom Jackson thingy, right? However, it needs to have a version. And here the version matters because here what I want is I want the platform to be versioned according to the version it sees in the graph. So for example, Jackson data format YAML 295 will say that it belongs to the custom Jackson 295 platform. Vertex requires a 298 version. We will have something that says, oh, I belong to custom Jackson 298. And what I do now is I actually apply the rule. So that's my Jackson 9 rule. Okay.
So again, you can do that in Groovy.
Yes, of course. Yeah, I'm doing it in Kotlin here, but in Groovy, I mean, in Groovy here, the syntax would be closer because I'm not using extension method or anything. So, yes. And so here, what I do now is I execute my thing. And what I see now is that YAML was upgraded to 298, which is strange because Vertex doesn't say anything. And all of the Jackson dependencies from Vertex were also upgraded to 298. So for example, Jackson annotations was bumped as well. And so I now have effectively a set of Jackson dependencies that all use the 298 version. With that, the thing that's interesting is that concept of virtual platform. But we've seen that there is a Jackson BOM. Can I leverage the Jackson BOM? Well, let's see. So what we do here is replace the coordinates of the platform with a real BOM. I'm keeping that version thing. I need the BOM to be my graph. So that's not what I wanted to do. I need the
false.
And I need to tell Gradle that this is no longer a virtual platform. It's a real platform. And so if I go back now to my terminal and issue again my compile class path command, I will see that I do have the platform, Jackson BOM, that it got upgraded to 298. However, it's bringing annotations 290 because that's what the platform defines. And so while YAML gets upgraded to 298, the Jackson annotations I have here at the bottom no longer gets upgraded to 298 because that's what the Jackson BOM tells me. So the benefit here is that I strictly respect what the BOM tells me. And maybe the BOM has a good reason for that. As you saw before, the upgrade to 298 was perfectly valid. Jackson annotations exists in 298, but the Jackson developers tell us this is not really needed. Like 290 is fine. And so that's a way where you get this alignment aspect. So again, quick recap for the people that would look at the slides online. You've got a virtual platform for the existing published libraries. You can name a virtual platform module. You enhance library modules metadata to declare that they belong to it. The platform collects the different modules, collects the different versions, and then performs the alignment. It is not magic again, it's science. Details in the code if you're really interested in that. There are a couple usability details around platforms. A virtual platform can only align to the versions it saw in the graph. We've got an example of that later. And a virtual platform will only attempt alignments. If you say that a couple of modules should exist all in version X, well, maybe some don't. And in that case, we will still have a solution. So that's the attempted alignment example. Jackson, again, sometimes does patch releases. But when they do a patch releases like 2881, they don't do it for all. Jackson Databind 2881 does exist. Jackson Core 2881 doesn't. So the platform will try to align all the modules to 2881 because it's the higher version. However, the modules that don't exist will then get, be ready, the highest lower version that exists for them. This is a complicated sentence. An example is better. If the graph saw 2881 and then 288 and then other, most likely the other modules would be in 288, like the ones that don't exist in 2881. However, if we never saw 288, but the next version we saw was 278, well, the other modules will most likely be in 278 unless they didn't exist, and then we go down to all the versions we had. So again, alignment works well as long as what exists out there provides the same level of consistency. We can't invent modules. Can you leverage an existing BOM? Yes, we've seen that. However, you still need the belongs to with that false parameter, and the alignment will be matching the BOM definition. And if the BOM does not align, well, then you're not aligned. That's the downside of it. If we go back to the Java platform plugin of Gradle, you can also use it for defining a platform for alignment. The way it works is that Gradle allows you to have a cycle there. So the platform will depend on all the modules. Each module depends on the platform, requires Gradle module metadata, though, to work in the wild, to work as a published solution. And so what it does is, you see the alignment platform. I've got a constraints on my common server and client projects, and each of the projects says that it uses the platform itself. And so whenever a project enters the graph of my consumers, it will bring the platform. The platform has a constraint on all the others. If anyone bumps the version, the platform bumps in version, adds a constraint to everyone, and all will rise at the same time. I think that was a lot of content. So now, time for a quick conclusion.
Yes. So what is Gradle? Basically, it's a set of tools for all the complex world that we have and trying to make sense of all the mess that is published everywhere. So it can be in your custom repository or Maven Central, whatever. The reality is that metadata is either broken or incomplete, or sometimes you don't need a feature, sometimes you just want to reduce the size of your project because you don't need this dependency, whatever. So there is a lot of complexity in dependency management, and Gradle provides this. But we don't want you to use a hammer when you don't have to. So what you have to understand from this webinar is that we want to model the different use cases that you face. So when metadata is wrong, there is something that lets you explain, oh, the metadata for this is wrong. When you don't use this version, we want a tool that provides you an information to tell this is not needed, etc., etc. When we do alignment, we want to say with the platform, okay, those things work together. Let's make sense of this working together. And eventually, if everything doesn't work, don't be ashamed if you want to use the hammer. But this should be the last resort. If nothing else works, or that you're just doing your project and never leak it to the open world, well, you want to use a force, and yeah, it unblocks you. So thanks for listening to this webinar. It was, 1 hour and a half. I think we're going to take a couple maybe of questions. And if you have more questions, you can post them on GoToWebinar, and we would answer them after the webinar as we get them. So I can already answer the first question we got. So regarding dependency substitution. So the question is it a physical change of the dependencies from log4j to symbol or whatever, or just replacing it during the run? So dependency substitution is not changing the jars, right? You still have, on the repository, you still have the two things. What Gradle does is that if you say it, you need this dependency and it has a transitive dependency or whatever, it first resolves the graph. And during the graph resolution, if it sees log4j and you say substitute it with something else, it is actually doing that. It says, in the graph, replace this with this other module, but it doesn't try to download the module, download the jar or whatever. This is really replacing this in the graph. And then when you're going to execute the tests, this is run time, and we're going to download the jars for this dependency. So it's not really physically changing anything. It's really substituting one dependency with one.
So there is another question which is about Gradle being able to suggest dependency in the graph that do not contribute to your current usage, and so mark them as potential candidates for exclusion or something. So as of today, Gradle itself doesn't have much in terms of that. There are some external plugins that will tell you, oh, this is a dependency you're using, or oh, this is a dependency you're not using. But you have to realize that one of the things we want metadata to say is, here are my first level dependencies. And after my first level dependencies, the only thing that interests me is their compile time dependencies. And that's where the usage comes from. Because one of the dependencies can say, oh, you know, I'm a caching dependency and I have effectively no compile time dependency because you're just gonna interact with my own API. However, at runtime, I may not only require other caching libraries from the same company or the same open source project, but I may also require logging libraries and more. But that doesn't matter because effectively your project is not using those directly, but they're still important for runtime. And so clearly it's a topic where we would like to have some improvement, especially with the Java library plugin and the API versus implementation scoped dependencies. And so we would like to find a way to enhance reporting and telling you you're using something that you shouldn't be using, or you're using something that you're grabbing transitively, but you actually have a first-class usage, so you should promote it to a first-level dependency, all of that. Specifics, timings, unknown, but that's something we realize is needed.
So another question is, if I'm the author of a library like Jackson and I want Gradle to tell consumers that all the components of this library needs to be aligned together, what do I do? So Louis explained that actually you need, of course, the setup of your project multi-module, but then you would do something similar to a BOM, which is in Gradle called the Java platform. So you have all your modules and then you add one, which is the platform. And this platform needs to reference all the other modules as constraints. It references all the other modules, and then for each of the module, they depend on the platform. So you create a full graph. So the platform depends on the module depends on the platform. So this results, because Gradle does the whole dependency resolution globally and takes all the versions into account, this results in natural alignment. So two aspects: if it is published, the platform is going to be published as a BOM for Maven. So you will lose the link from the dependencies to the platform. But if you use the new experimental Gradle metadata format, which is going to be enabled by default in 6.0, it publishes this platform as a real Gradle platform, and then the Gradle consumers would get the alignment. So Gradle gets the alignment and Maven would get whatever it gets. So if they import the BOM, they would get some kind of alignment. I think we're pretty much done in terms of time for questions.
Yep.
Just maybe show the sneak peek for the next
Yes,
one.
I'll do that. But also with regards to questions, so any more questions that appear between now and when we completely close this, we'll try to answer offline so that you have an answer to your question. So the next thing, because when Cedric and I looked at this second webinar, we realized that we have way more to say. So there will be most likely another webinar, again on dependency management. What we're currently considering, and again, you know, this is software, the whole thing, so don't take our word for it. But what we would most likely focus on is that aspect of publishing and the importance of the Gradle module metadata. And that would allow us to cover what to publish, how to publish it, what happens when you really want Maven and or IV compatibility, what it means to publish capabilities, what it means to publish alignment, so back to the questions Cedric just answered. And also some of the things that were introduced recently in Gradle or will be introduced in Gradle, like feature variants and test fixture support. So that would be the next thing. And time-wise, definitely after summer.
Yep.
So yeah, but not too long either. I think we quite like the fact that having like around 3 months between the two webinars was a nice time. So thank you everyone for attending. Please, if you've got questions, as a reminder, we have a community Slack where you can interact with other Gradle users and some of the Gradle developers. There is always discuss.gradle.org, which allows you to ask questions. Keep them coming. We're interested in what you're doing with all the tools we're putting out there for you. Thank you.
Thanks. Goodbye.